All right, for this lesson, it's a continuation of 3-2 that you did for your last lesson, and so you don't need to write down a new title page or a new table of contents. Just continue it on from the notes that you were writing before. So we have learned how to solve systems by using a table, by graphing, by substitution, and now the last method we're going to learn is elimination. So go ahead and write down the steps for the elimination method. And now let's take a look at an example. The elimination method, also called the addition method, the goal of it is that we're going to add the two equations together and one of the variables will cancel out. So let's just see what I mean by adding the equations together. In this case, we could draw a line under it and we'd get 2x plus 3y equals 16. Unfortunately, though, neither of the variables canceled out, and that was our intention. So what we can do is multiply the equations by a number, and that way then it will make it so that they'll cancel out. Now I notice here that I have both x and x in these equations, and they're both positive, so that's why it made 2x. If I could make one of them negative, it would make 0x's and they would cancel out. So what I can do is multiply either one of the equations by -1. I'll just choose to do the second equation. I'm timesing it by -1. So the top equation stays the same. The bottom equation becomes -1x, or just -x, and then -1y, or just -y, and then it's -6. Now when I go to add these two equations together, the x's make 0, so they can cancel out. And then it's 1y equals 4, or just y equals 4. So we solve for y pretty quickly. And then we can solve for x by just substituting 4 into either of the equations for y. Looks like the bottom equation is a little bit more simplified. So let's go x plus 4 equals 6. Okay, then just solve for x by minusing 4 off of both sides, and x equals 2. So to write this answer as a coordinate point, we would say 2, 4. All right, let's try another problem. Now, when you look at this one, nothing seems to match up at all. And so we're going to have to find the least common multiple for either the x's or the y's. Now looking at my x's, they're both positive, but we know to be able to get 0, we need one positive and one negative. So it looks like our y's are going to be a better choice. Now we need to think about what do we want for a number in front of y. What's the least common multiple of 2 and 3? And so if you can't think about, or if you can't do this in your head, you list out 3, 6, 9, 12, 15, all the multiples of 3. Then you do the same for 2. And you go until you find one that's in common, the least number that's in common, which would be 6. So we want to see a 6 in front of the y. So then you think about what would you multiply the top equation by to get a 6 in front of the y? And you would do 2. What would you multiply the bottom equation by to get a 6 in front of the y? And you would need to do a 3. And so we're going to rewrite these equations as 4x plus 6y equals 24. Now when you do this multiply, make sure that you multiply the entire equation, all numbers in it, left and right side. And then the bottom equation is 15x minus 6y equals 33. Now when we go to add these two together, the 6's will make 0, and we have 19x equals 57. Okay, working into the problem there a little bit there, into the answers. Divide both sides by 19, and we end up with x equals 3. Now to figure out the y value, we just substitute x into either of the equations for x. And I'll just pick the top equation. So 2 times 3 plus 3y equals 12. And we'll just work this one out. Subtracting 6 off of both sides. And then dividing by 3. And so we get y equals 2. So if we'd write that out as a coordinate point, it would be x is 3, y is 2. D would be our correct answer there. Okay, so we also have a type of problem where there could be no solution or infinite solution. So let's just take a look at what those look like. All right, we are ready to use elimination on this problem, except for we don't have either the x coefficients the same or either of the y coefficients the same. So I'm looking for the least common multiple, and let's just try for the x's. So we have a 3 and a 6. So the least common multiple is 6. So what I need to do is multiply the top equation by 2. Get negative 6x plus 10y equals 24. And then just copy down the second equation. All right, now when you add these two together, you'll notice that the x's cancel out, but the y's also cancel out as well. So really we have nothing over there. We have 0 on the left-hand side, and that equals 3. Now we have to decide, is that a true or a false statement? 0 does not equal 3, so that is a false statement. And because it is false, it is considered no solution. Now, if we were to graph these equations, it would be two parallel lines, and that is why they never intersect. So that's why there can be no solution to it. Okay, let's look at another type of problem. Again, we're ready to try out substitution on this, except for nothing is matching up yet, so we're going to try to get them to match up. Let's multiply the top equation by 3 so that our x's will match. But then as we can see here, the y's are matching up as well. All right, so now the x is canceled out, the y is canceled out, and the other side canceled out. So we really have 0 equals 0. And this is a true statement. If it is a true statement, it is infinite solutions. And what this means is if you were to graph the equation, you would graph one line, and then you would graph the second line, and it would be the exact same line. So every point along that graph is a solution because it's always touching, always intersecting. Okay, we have finally completed the lesson. But if you would like to copy this down, I'll leave it up to you. This is how to help you decide when is the best time to use each of these methods: table, graphing, substitution, elimination with addition, elimination with subtraction, and elimination with multiplication. I think for most of you, you'll want to just pick out which one do you prefer to use and use that most often. Sometimes you'll be able to just decide that I like this method better for this type of problem and this method better for this type of problem. It doesn't really matter. They're all going to get you the same answers. So go ahead and write down your questions and your summaries, and let me know if you have any questions.